This is exciting. I've got Mike back with me, and we're joined also by Martin Casado. And I want to tell a quick story before I kick it over to Mike for the intros. The first time that I ever Googled Tecton, I randomly saw this video of two guys talking on what looked like kind of like a CNN style interview. And it wasn't CNN, but it had like the ticker below. And they were being interviewed about what is machine learning, what is operational machine learning. Turns out that was Mike and Martine giving an interview. I don't know, I think it was probably like 3 years ago. We'll get the full story on that in a minute. But now,
Must have been.
Mike, can you give us a little bit of an intro here of who we're with?
Great. Yeah. I'm excited. This is a conversation that I think should be pretty fun. So Martine is joining us. Martine is a general partner at the venture capital firm Andreessen Horowitz, and he focuses on enterprise investing. Previously, he was co-founder of a company called Nicira, which was purchased by VMware for more than $1 billion. And he's been a founder, a senior executive. He's now an investor. And the reason we brought Martine on today, he's super deep in the data and machine learning space. He's an investor in some of the most influential and disruptive companies in this space. And he's truly a master of recognizing trends early on and reading the tea leaves of quickly changing markets and communicating those insights in ways that can be very educational for a broad audience. So I thought it could be fun for us to chat today, the three of us, and just talk about some of the stuff of what's going on in the machine learning world. And maybe I can kick it off. Well, so welcome, Martine.
Happy to be here.
Maybe I can kick it off. You know, Martine, you've seen thousands of pitches from early stage ML companies, data companies, of the and they all promise different things. Of these promises that you've seen in these different pitches over the past few years, what has become a reality and what is still in aspirational state? Like, where is ML delivering and where is it under delivering?
Yeah, so I think in order to answer this, it's helpful just to provide kind of the continuum of views and then answer within that, right? And so I'm gonna give like everybody listening to this mental bookends. So on the most bearish is AI ML is nothing new. It's basically regression that's expensive, and like not very accurate. And, it's a bit of a lark. And then, we'll go back to actually doing real statistics. Like that's the most bearish thing, right? The most bullish on the continuum, the most bullish it is actually so powerful and it does so much that we as humans don't ever need to even have theories anymore. We can just set up the grand AI and it'll decide what we're going to do with our lives and what our apps are going to do, right? And the big question I would say over the last decade is where in this continuum does reality lie? And here's what we think, and here's what we're seeing, which is there's absolutely something innovative and something new. Absolutely. And it's quite likely both an evolution of the consumption layer of software, like a way to interface with human beings, but it's also an evolution in how to understand the world when it comes to dealing with like non-state machines and non-structured data. And the implication is going to be that not only are apps more suited to aid in what we as humans want to do, but it's going to push software into domains that it hasn't been able to do before because it is particularly suited for navigating the real world and dealing with real things. And so we believe strongly that it is a leap forward. We believe strongly it has real implications. What we don't know is how far that goes, and we do feel, just to keep us all grounded here, that this doesn't in any way cut humans out of the loop. It's not the end of theory. It's just kind of navigating these two domains very well.
And can you give us some kind of granularity on what maybe some of those middle stages of the spectrum that you've thought of are? Because like we understand the bookends, and I think everybody would say, hey, we don't want to be, I mean, a lot of people would want to be at the one side, but everyone in this conference is very grounded in reality and knows that we're not at that end. But what's some of the like intermediate steps?
Well, let me give you some examples. So we have companies that come in, and I call these the end of theory companies. And they're like, we have we have access to data, and we're going to apply ML, and it's going to tell us something. And I don't even need to have a theory of what that something is because the AI is going to tell us how it's valuable. And then you're basically resorting to the AI to do things like, find something interesting or find product market fit. And so for these, you have to believe that AI will, spell an end to needing even a theory of what you're solving. Um, and so I think that is too bullish. I think that it is a tool that is applied quite commonly to a builder's theory of what needs to happen. So I put that in the too bullish camp. Um, on the other hand, we do see companies that say, hey, listen, we've wanted to digitize a lot of the world. Let's take, for example, documents. In the past, it's been very difficult because documents are tremendously unstructured. But, let's say you're doing like, I don't know, pay stubs and
Medical records.
or medical, the kind of example. Yeah, right. And, there is no axiomatic or rule-based approach to solve this problem because the space is too large. We can provide a step function in accuracy based on innovations that have happened in the last couple of years. The same thing you could say with natural language, et cetera. And we're going to apply these to domains that there already is software and there already is a software buyer, but now we're actually going to be kind of more accurate. So that, we see a lot of those, and those are doing quite well. And then, to go, I would say, so some are too bullish. There's that, and then there's some are too bearish. We definitely have companies that come in and say, DNNs are great, and all, but like, we don't think that humans want to deal with, fuzzier data. And we actually think that if you don't understand this evolution in AI ML, as far as expectations around personalization, around fraud, et cetera, I think you will be left behind. So anybody that isn't taking this stuff seriously, we actually believe is going to become a laggard quite quickly.
Fascinating. I think it's also interesting to think of that spectrum in terms of like what are the applications. So you can think of it in terms of end of theory. So what applications are enabled by each of these different stages, but also what is the tooling that is needed to enable each of those stages. Like if that is where ML converges, the true value, of ML converges long term, then what is the corresponding tooling and a variety of other implications for the industry. And so we're pretty clearly, so ML is pretty clearly something that's different than software engineering. We're building new teams, there's new roles, there's new technologies, etc. So where do we think it's all going? Is machine learning fundamentally different than software engineering, or is it just a a sub-discipline of software engineering?
Right. So to just go to like how you opened this segment, which is, yes, there's the types of AI companies as where they are on the continuum of like bearish to most bullish. But that's not the extent is like applying AI, right? There's a whole set of tooling. So I think it's actually worth talking through, how do you kind of break down this AI market, quote unquote AI ML market a little bit more, right?
Yeah.
And so the way that we segment it is in two pieces, right? We kind of view broadly this notion of analytics, which I would call like computer aided decision making, and then the operational IML. And then, everybody listening to this understands this, but I actually think it's quite instructive relative to the question you just asked, what these two buckets are. So the analytics one is it's really kind of an evolution and extension on traditional analytics, where you've got a bunch of data sources, you go put them somewhere, and then you do kind of dashboarding and you do reporting and you do whatever. But like the assumption is that whatever that result is being consumed by a human to help with human-aided decisions, right? I mean, that's, if you're talking BI, if you're talking things like CDP, like a lot of these analytics use cases. And then, of course, on the operations one, you're believing that it's now fundamentally part of the program, right? So, and it can be anywhere within that. It can be anywhere within the program that it's being used. And so I think.
Do you see? Sorry to interrupt, but do you see a fine? Is it very binary every single time on which side of the kind of distinction use case lands?
You know, it's interesting. So I do. I actually absolutely do. I think these are two distinct technical problems. I think,
Hmm.
you know, what's interesting is I actually think the problems are more distinct than the tools you need to solve them. But for whatever reason, the tools follow the
Hmm.
problem, right? So I would say, if you're building a system to aid in human-aided decisions, you know, like that problem statement is very, very different than like, I need this to be a core decision process within an application that has, you know, like correctness constraints and it has, you know, performance constraints, etc. So I just think that they're two very distinct problems. What's interesting is there's a lot of confusion on which tools apply to either of these, right? And
Yeah.
you know, and I do want to get to the kind of like the capstone portion of your previous question, which is like, okay, so like, you know, is this just computer science, right? Like our, you know, like, okay, you've said analytics, you said operational ML. Can we just go get our tools that we've had from programming for a long time, apply to it? I actually think the answer is not really, and I think this is an interesting, very interesting discussion. I don't think you can just go to like the tools that we've developed as, you know, systems developers over the last 20 years and just say, okay, now I can solve, you know, the operation of my AI/ML problem. I think that the tool set has to be quite new.
And and is that because there's something fundamentally different about machine learning than a traditional software engineering, or is it just
Yeah,
that,
right.
hey, we have to do slightly different workflows now, so we're just kind of choosing a slightly different place in the design space that's kind of
Right.
optimized for different tasks?
Yeah, so I don't want to get too philosophical, but I think it's actually fundamentally different. So and listen, I'm open to the fact that this is a very much an open question right now. But when it comes to system buildings, which is the root of software engineering, which is very much an engineering discipline, you're dealing always with a finite state machine, right? And you're constructing it and you can control it. And therefore you can apply these, you know, tools and practices that we've developed to constrain the complexity, right? You can use things like modularity. You know, you can use things like virtualization. There's just a lot of tools that we've come up with to reduce problems to solvable components and then stack those up. I think when it comes to the domain of building solutions for ML, it's quite different because now you're trying to rein in the complexity, not of a state machine you're building, but like the natural universe, right? It's like, how do you rein in the complexity of language? How do you rein in the complexity of like, you know, anything you could ever look at? Or how do you rein in the complexity of like action, right? Like things like even just action detection, like, you know, like somebody kicking something or whatever, like, you know, like the state space is all the atoms in the universe and then some.
Yeah.
And I don't think that we as a discipline have developed the tools or formal tools to actually manage that. So I think that we're entering a new realm that requires new skill sets and new tools, et cetera.
It's kind of interesting to think about. Like you mentioned, finite state machine. I'm just thinking about, okay, so does that mean, you know, we are kind of the needs, the compute needs that we have are kind of evolving past what a finite state machines can easily be applied to. And I'm thinking about whether is that because there's now we're moving into a world of from a limited amount of states to, or from a finite amount of states to unlimited number of states, and we have to be able to account for that? Or is it more about when we're building machine learning systems that are handling this kind of crazy complexity in the world, it's actually that there's not discrete states, but rather
Right.
continuous states, and it's kind of all kind of jumbled together, and that's some kind of like uncertainty that has to be managed throughout the compute of an application.
Yeah, yeah. I think the machines that we've built, you know, computers are the right architecture for pretty much anything like that. I believe. I just think the nature of problems we're solving require more than software, right? And so they
Yeah.
require software. They require software and. So for the software part, we should use what we know how to use, right? So for example, you know, if AI is part of your component, you need to really understand like how to build a distributed system and like how to handle data very quickly and how to support SLAs. And you use all of the system tricks to do that. You use virtualization and scaling and caching and, you know, I mean, and so that is very much part of the solution. So this is why I think that like AI/ML is a superset. However, that is necessary but not sufficient. Now, in addition to doing all of that, you also have to have some set of approaches for taking this data, which is very messy, which is not under your control, which to your point can be analog as opposed to digital, has this enormous state space, and now you're supposed to put structure on that. So not only are you building something from a state machine on up where you control everything, and so you can kind of limit the complexity. Now you have to take in things that's already complex and then find out how to rein in the complexity from that. And again, I think this tooling moves into like more what we deal with, in like physics and math and stats.
That makes a lot of sense. And I'm just trying to think through like, what is this kind of software plus these new requirements? We're kind of taking these as a new set of requirements for the applications that we're building, a new set of capabilities that we need to be able to handle. I'm trying to think through what does that mean for the different layers of our stack today, right? Does that have different implications for the different layers of the stack, or does it just mean, hey, there's some new layers of the stack that we need to be adding?
Well, let's work from the organization on in.
Sure.
Because I think that's kind of the clearest on this. Like, I think it's pretty clear to say that you need people that understand this stuff, and like you don't learn how to like rein in the complexity of the universe building software. I mean, this is just a very different type of thing. And so there's definitely the role for someone that says, I'm going to stare in the face of all of the chaos and complexity of the universe, and I'm going to extract kind of like, features or things that we can now use in a program. And so I think that there's a certain skill set in the organization, and I think that organizational skill set must map to a set of technologies to help them and a set of tooling to help them. And at some point in time, this insight from this team translates into things that we as systems build. I mean, I'm a systems guy, you're a systems guy. We as systems builders know how to use, and then we're back into, traditional systems building.
And just on that point, for the average data scientist or engineer who's listening to this, I'm thinking through like, what does this mean to them in terms of for the whole idea of like reining in some of this complexity of the universe? More concretely, does that just boil down to being really good at adding structure to data sets where there's no structure, or information sets where there's no structure, or is there another set of tasks that comes to mind as well that's a little bit like more concrete that folks can think about, as in like, hey, I do this today and this is actually pretty important for me to be great at in the future?
So I would actually, it's interesting. I mean, you have so much on the ground experience with this. I would love to hear your answer on it, and then I'm going to color it with mine, because yours is going to be much more rooted in what's practical. And then I'm going to provide more of kind of like a VC trend one, if you don't mind.
For sure. One thing that I have found quite interesting is that you never really have a raw data source. Everything's always derived data. Like the original raw data is atoms somewhere, and you got to take the analog world and turn it into digital. And so there's no raw data source that you have. So when I think about adding structure to unstructured data, or to wrangling a lot of complexity, to me it's not just the task of taking the raw world, the raw data, and further refining it, but everything is always some derived data set. And so it's not just at the beginning stages of things, but I think you need to apply that skill throughout. And people talk about bronze, silver, gold data sets. There's all these different ways to say you're an unmodeled data, your modeled data, and then your super refined data. And we talk about, feature engineering as a very specific example of refining data to extract out the most important information from that data set that can be easily consumed by a model. And so when I think about it, I think there's kind of two elements. There's being really good at that task, at really figuring out like, how do I tactically extract out this information from this data set that I have? But then secondly, there's the kind of higher level reasoning about like, what could this data set contain? And understanding, outside of what is in my data warehouse, like what data sets could be out there, kind of the meta layer management of the information that can flow, and design that information that could flow into your application. And I think that's the kind of thing that is not going to come from an AutoML product or something like that. It really requires someone to deeply understand what's going on in what is the big picture here for this application I'm building? What is the data? What influences what? Having a solid mental model of causality here. And that's something that's kind of hard to teach also. And so I don't really know like exactly which course you should go take for that, but I think it affects, it is like a real trait that some of the best ML people that I've worked with are just really good
So
at.
I want to add, so I totally agree. I'm just going to add one more aspect that I think is very important, which is, um, ultimately, if you're building these models, you're trying to do something predictive based on the data that you've looked at. And the extent to which that prediction can ever be accuracy or ever be useful is actually contained in the distribution of data before it gets loaded in it, right? And there are some problem domains which there just is no notion really of being predictive, right? So like the classic example of this is self-similarity, right? And so there's all of these statistical distributions that are latent in the data that if you know them beforehand, you can even know whether you should actually solve this problem or just go spend 6 months at the beach because you're going to end up at the same place, right? So I'm going to give two examples where, like, I've seen this in real time, which is so, I have looked at companies that claim to be building chatbots for certain domains, and they've been working on it for a very long time. And then after we actually dig in the data with the company, there's a realization that even though, let's say, they can answer 80% of the queries, they're all the same query. Let's say it's a password reset. And as far as the uniqueness of queries, they can answer less than 50%, right? And it's not until you actually have built it do you know where this is going to end up. And there's nothing to do with the accuracy or inaccuracy of the model. It just turns out that that's the distribution of data. I'll give you one more example. So I come from the systems world, right? So like I did my PhD in computer science, focusing on building systems. And a lot of what you want to do is like predict network traffic. And if you could predict network traffic accurately, there's a lot you can do for like smart routing and things like that, right? So you could do kind of an optimization at the networking layer. And there's a reason why we really haven't done that. Like data centers, they don't like route traffic smartly. They just basically send it to random locations. And then on the end, because that's within a factor of two of optimal. And the reason is in most network environments, the traffic is self-similar, meaning that no matter what zoom level you look at it, the stochastic properties are the same. So like to even try to apply machine learning to this problem doesn't really make sense in those cases. And yet we see many people trying to do that. And so what I would say is before you even start, you can have a decision to work for 6 months or go to the beach for 6 months. You should answer that question. And if you're like, actually, this is pretty well behaved data because we have the distributions, then I think that you should tackle it. And there's many that fall in that bucket, but so few people ask the question before they embark on it.
I just want to mention that I see the same thing in companies as well, where they will be,
Totally.
I'll talk to an ML platform team and same kind of meta challenge where they will be working on, the ML platform team will be funding 5 or 10 different ML projects, and a good number of them will just be things that you shouldn't be using machine learning for. They will just be things that you kind of intuitively know are doomed to fail, and not because of their execution, but just because of it's just not a good problem to apply ML to, and there's some like kind of intuitive I don't know, you learn some intuition on this,
Well,
and that has, go ahead.
let's just be very clear about this, Mike, because I think this is actually a great discussion. Which is there are some problems where linear regression or whatever is fine, and it's just stupid to apply AI ML
Yeah.
because it's just too heavyweight a solution. It's not optimized. But that's one problem. There's another problem, which is yours, which is intuitively it's kind of like not the right domain. It's not going to be accurate enough. The state space is too large. You don't have enough, right? There's a third one, which is the one that I was talking about, which is you actually have the data. It does seem like a good fit, and yet you still don't know unless you actually understand the distribution of the data you're looking at. And the third one, I think all three of those things you can take steps in your career to make better decisions. The third one requires a skill set that we have not been trained on as computer scientists.
And okay, so D, I'll let you jump in here. I know you had some internet troubles. You hopped on and off.
I'm back now. I'm looking good. Yeah, I find this fascinating. First, what you were talking about, Mike, how certain star players can figure out what is the creativity, figuring out how I can go outside of the box and find that data, or how I can use that data in a different way to get me the results that I want. And then, Martine, what you're talking about, where there's just certain problems that don't necessarily, it doesn't matter what resources we throw at them, they don't need to be solved with ML, or they shouldn't be solved with ML.
And
They
you can't
can't be
tell
solved
ahead of
with
time.
ML.
Well, I'm actually saying they
Yeah,
cannot. They can be statistically proven not to provide predictive
that
results
it,
based on the inherent structure of the data. Exactly. And it's
and that's
shocking to me.
fascinating.
It's shocking. I mean, listen, I'm a VC. Like, what the hell do I know, right? It is shocking to me how many people walk in with a pitch. I'm like, okay, great. What's the distribution of this data? And they have no idea. It's like step number one before starting to form the damn company, right? And so I do think that this is such a great example of why we as an industry have to evolve to think more broader and think more like scientists in addition to being engineers.
And I mean, going down that road a little bit more, when there's something that you just said, what's the distribution of the data? They don't know that. Are there other signs that you would look for to save us that 6 months of pain after, and let us just go to the beach?
So there's many. Again, Mike, you've seen this in practice. I've got some, but they're kind of again from the VC side. So I'd love to hear your view, and then I've got two in particular that seem to be.
I can speak instead of kind of like a theoretical angle to it. I can speak on a very practical perspective of when is a machine learning project like not going, when is it not off to the right start? And there's a variety of things that everybody
Doomed to fail.
we all know, right? You need the data. So like so many times you're trying to solve a problem and you don't have access to the right data. These are kind of like common things. You don't have the right team staffed up, so you don't have the right skill set on your team or the ability to hire the right people. But one of the other things that I've seen recently, which is kind of interesting and probably good for like everybody who's listening to kind of think about this for their projects, is do you have the right level of organizational support? Do you have the right level of executive support for your application, for what you're doing? Because putting a machine learning application into production, it takes a lot of work. You might have to buy some tools. You're gonna at least have to staff up a team. It's expensive for your company, and doing that is an investment. And I've seen a ton of teams where the engineer, the data scientist, they're like, hey, let me solve this problem with machine learning, and they embark on that journey, and then they find out, hey, you know what? I'm running into some things aren't working. I'm able to get an accurate model, but I'm not able to get this thing into production. What's happening? Well, you just don't have the organizational support. No one's giving you any engineer's time to put this thing into production. And what I most commonly see is it actually is not that important of a problem that you're solving. It's not that valuable of a problem. It's an easy problem to solve with machine learning, but maybe there's not the business perspective behind it, the business value behind it, and someone who's a little bit higher up in the organization is just not willing to invest in it. And so that kind of like business level prioritization is something that I think is underappreciated by data scientists and engineers who just want to hop on to every problem and solve it with machine learning. And so that's kind of like one of the things that I've seen kind of lead these problems to these projects to be less successful.
I think that's the perfect answer. I will add that I have experienced through being on boards and working with a number of companies in AI ML that there is an underappreciation often at how hard it is to just build data infrastructure, like keeping things fresh, keeping it clean. Like, I mean, it just, often, the companies I invest in are seed stage or A stage. And the amount of effort that's required to do it, and many don't even actually do it. And so I think actually, in addition to aligning with business value, which Mike said, which is 100% correct, respecting the organization and make sure you've got the organizational challenges figured out, I think actually understanding the extent of engineering needed to do something that can be production ready.
That's a very good point, and I'll just share. I think we're up at time, so I'll just share one kind of final anecdote, which is there are that kind of organizational capability to internally execute on one of these projects is so important. And we've seen it again and again where we'll talk to an organization and it just they'll be in a situation where we're going to build everything. We're going to, we all know these companies where they build everything internally, and and this part of our sales process to chat with them and see if they, if we can help them out. And it's not uncommon that I say, okay, you guys should try to build it, and I know that I'll see you in my inbox in 6 months from now. And this just happened yesterday. We had really big company that everybody knows come back to us after a couple of months and say, hey, you know what? We tried it, and it actually is way harder than our engineers, our hotshot staff engineer thought at first, who said, oh, I can do all of this really easily. It kind of reminds me of that Hacker News reply to Dropbox, the Dropbox kind of launch message a long time ago, where someone was like, you could just do this with rsync. And so I think you remember that. And so
Yes.
I think that's like a thing. Like, I see that as a theme again and again, where the engineering teams may understand technically how to build a system, but it underappreciate what it means to operate a system at a business for solving a business problem long term.
I just want to wrap up this entire conversation with two comments, which is, so on the positive side, I'm a VC. Like Mike said, I see thousands of pitches. My team sees about 3,000 a year. I mean, it's a lot. And I would say at least 60% of those are in the AI ML domain. And when companies come in, no matter what the company is, they all kind of pitch, whatever they're doing. And often we get companies that are doing the same thing. Let's say it's, doing like, file sharing or whatever. And more, the way that companies differentiate is how they use data, right? It's things like fraud detection and personalization and pricing and matching. And like if you take 5 companies that look the same and you line them up and they all pitch at the same time, really the way they're differentiating is like how they're building the AML infrastructure. So in that sense, this really is probably the most important current trend in all of systems. And I see that up front. And so one big takeaway is like, this really is the future. It really is real value, and you should continue to be investing in this, and this is what differentiates company. But I think Mike made absolutely the correct, capstone point, which is it's one thing to say that, it's another thing to build it. And it just turns out that we're appreciating the level of complexity. And so just really understand what you're getting into and make sure that you're partnering with, the right people when you do it.
Thank you, Martin. Thank you for your time. This is a great
Yeah,
conversation.
always, man. Anytime.
Super cool.
That was
Awesome.
great. Thank
Okay.
you.
Thanks, both of you.